This is a video about solving trigonometric equations with the sine function. In this video I'm going to solve these three little equations, and I'm going to use the sine curve to do that. It's just y equals sine x. We're using radians, so the sine curve is cutting at 0, pi and 2 pi, and going between 1 and -1. We're going to use that curve to solve all of these equations, even this one. We're just going to use this curve. We'll start with this, the simplest example. And the first thing to do when faced with a trig equation like this is to get an initial value for your solution by taking something like, taking exactly the inverse sine of 0.6. I'm going to use a calculator, and I'm just going to take the inverse sine of 0.6, and it tells me that that's 0.644 radians. Okay, so that's my initial value. Once I've got that, I'm going to use that with the curve to find other possible solutions. And I should have said, we're looking for all solutions here in which 0 is less than or equal to theta is less than or equal to 2 pi. You'll always have some kind of range of solutions in which to find the answers to your problem. So I'm going to draw the sine curve like that, and it is cutting at 0 and at pi and at 2 pi. And the places that I'm interested in are all the values of theta for which sine theta equals 0.6. So that's going to be running across here somewhere. And we can see there are two solutions in my range from 0 to 2 pi. And here they are, at this point and this point. The calculator has told us that the first solution is 0.644 radians. What we've got to do is figure out where this second solution lies. And the way we're going to do that is by the symmetry of the curve. This sine curve is just the same bit from here to here, folded round and flipped over and folded down. And so that means that this distance here must be the same as this distance here. Okay, these two distances are the same. And so that means that this point on the x-axis is actually pi minus 0.644. So by using this initial value that we got with an inverse sine and the symmetry of the curve, we found two possible values for theta that fit within our range. Okay? And because I haven't got much space on this little board, I've got to rub this out as we go along. So where we've gotten to, you keep going down. If you're copying this out, you should keep going down underneath this. So where we've gotten to is that theta equals 0.644 or pi minus 0.644. Okay? And again, we can use our calculator again, and that's going to tell us that 0.644 and pi minus 0.644 is, I think it's 2.498. And so those are our two solutions to the equation in the right range between 0 and 2 pi. We found the two solutions. So that's the first example.